In section 10.2, we're still going to be talking about circles, but now it's more about the angles, so different types of angle measurements, so such as minor arc, that you can see here on this fold on our pink paper you're going to be writing. So minor arc, major arc, central angles, what that means, and I still mentioned the diameter here, and we have a semicircle in the different degrees, the way we write them, and the degrees and how we're going to find them. So this time we have a pink circle, so you need to cut out your pink circle from class, and you're going to copy all this information on there. If you notice again, if you fold your circle in half, you can draw a line through it, and that's where this diameter is coming from. If you fold it in half again, you can't see it, but mine was folded right here, and then that's how I found that my point B, that's the actual halfway point. I used a protractor and actually did find the 58 degrees right here for my angle, but what the central angle is if the angle, the vertex of the angle is the center of the circle, so angle ABC is 58 degrees, then that means also that when we do the arcs, that the arc measurement of AC is the exact same measure. So up here, our minor arc, the measure of AC is going to be equal to 58 degrees. Minor arcs are always going to be less than 180 degrees, and think of it in a circle, that 180 is half of the circle. So any arc on the edge right here that is less than 180 degrees, you're only going to use 2 letters to name it. That's how you know it's a minor arc. So for my A to C right here, that's a minor arc because it's less than 180 degrees, so I'm going to use 2 letters, so just from A to C. If I want it to be more than 180 degrees, that's considered a major arc, and I use 3 points instead. And the reason we do that is, say I want it to be this whole arc right here, that if I use just AC, I wouldn't know if you wanted this piece or if you wanted the other piece of it. So we need to use 3 letters. So A, D, C is an example right here of this outside arc, or major arc. And since we know that the whole circle around is 360 degrees, I can subtract off the 58 that I know it's not, and that's why I know that that angle will be 302 degrees. So major arcs are more than 180 degrees. I use 3 points to name them, and I gave another example here because this 122, the rest of my diameter, because this would be 180 together, so 180 minus 58 gives me the 122. So CAE, so C to A to E, so everything except this piece would be 238 degrees. So from here all the way around is 238 degrees. Next, we've got a semicircle is between the minor and major because it's exactly 180 degrees. So think of your diameter cutting it in half. So this is a semicircle and this is a semicircle. So I could say arc A, C, E, or I put ECA right here. So E to C to A. Or I could do from E to D to A. Notice it has to be 3 letters again to name it, and it's exactly 180 degrees. So one thing you can also do is to know that it's 180 degrees, you can add the pieces together. So 58 plus 122 gives me 180, so that's the reason that this would be your semicircle. So a few more vocab words thrown in here. We have adjacent arcs. Remember, adjacent just means it's next to. So it has to be from the same circle, first of all. And they have a common endpoint. You can add the measures of 2 adjacent arcs together to give you a bigger arc. So arc addition postulate just means that we can add different pieces together to give us a bigger angle. So the measure of an arc formed by 2 adjacent arcs is the sum, so sum is in adding, the measures of 2 arcs. So if you look at our picture over here on the right, we have that the arc A to B to C, so notice it's a major arc because it has 3 letters and it's bigger than 180 degrees. You can take arc AB and add it to BC to give you that full arc. So you can add any of the pieces together still to equal the whole thing. So next in our picture right here, first, before we find out any of these other missing degrees of what those arcs are going to be and what type they're going to be, what we want to do is find all the missing angles. So if we know we've got 180, 120, and 60, to find this angle, we can take 360 and subtract off all of the numbers we do have. And that gives us exactly 100. So that means this angle right here is 100 degrees. So going on to letter A, we have QT. So from Q to T is just the 120 degrees. And because it is 2 letters, it is just a minor arc. Next, if you look at the rest of your choices, this would also have to be a minor arc. And so would E. And that's only just because there are only 2 letters. So if there's 3 letters, it's either a semicircle or it could be a major arc. But for the 2 letters, it has to be a minor arc. So those we can do real quick. So let's find those pieces first as well for the degrees. So Q to S. So Q to S, if you look at it, you only want 2 letters, so it has to be less than 180 degrees. So you want the shortest distance from Q to S. That would be this piece right here. So we want to add the angles together. So 60 plus 100 would give us 160 degrees. All right, so from T to S, so T to S, the shortest distance would be 80 degrees. That one we don't have to add anything together. All right, let's go back up to QRT. So you want to start at Q, go to R, and then to T. So Q to R to T. So we have these 3 pieces we have to add together. So you're going to be taking your 60 plus the 100 plus the 80, and that's how we end up with 240 degrees. It's not equal to 180, so it is just a major arc. So if it equals exactly 180 degrees, then it would be a semicircle. Next, for Q or TQR, so T to Q to R, just as these 2 little pieces. So 120 plus the 60, so we get 180. Because it is 180 degrees, we know more specifically that it is a semicircle. For the last one, RST, so R to S to T, we have to add the 100 and the 80 together. So we get 180 again, so exactly 180, so this one is also a semicircle. So for number 2, if we need to find the measure of each arc of the circle, and RT is the diameter, so that means that if our 110 is right here, we know the whole thing across needs to be 180 degrees. So I know that this missing piece has to be 70 degrees right there. So we want to fill that in. Then because it needs to add up to be 360, I can take 360 and subtract my 110 and subtract the 70, and I get 180. So this whole side over here is going to be 180 degrees as well. Okay, so if I want to find the RS, notice that that's going to be a minor arc again. So it should be less than 180 degrees. So from R to S, the shortest distance is only that 110, and that is it. All right, so for RTS, R to T to S, so follow it around, so I have 180 plus the 70. So 180 plus the 70, and I end up with 250 degrees. And it's not 180, it's bigger than 180 degrees, so it's a major arc. Then for RST is the other direction around, so I have the 110 plus the 70, so I get exactly 180 degrees. So this more specifically is a semicircle again. All right, so for number 3, a recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in the circle graph. Find the indicated arc measures. So if you notice, it gives the different degrees of our different pieces in our circle, and it's the same general idea. We just want to add the different pieces together if we need to. So the measure of arc AC, so look from A to C, it's a minor arc because there's only 2 letters. We have to add these 2 pieces together. So we need to take our 108 plus 29, and we get 137 degrees. Next, for letter B, A to C to D. So we've got the 29, 108, and the 83 we have to add together in that one. So 29 plus 108 plus 83. Then we get 220 degrees. For letter C, we have from A to D to C. Okay, so we have to go this way around. So A to D to C. So we have the blue, green, and yellow we have to add together. So that would be, let's see, 79 plus 61 plus 83. And we get 223 degrees. Lastly then, from E to B to D, so that's the long way around, we have to have everything except the green. Okay, so a different way we could do this instead, if we know the whole thing is 360, we know it's everything except the green one. So I could subtract the 61 instead, and I would get 299, and that might be a few less steps than adding up 4 of the pie pieces. So we have 2 more vocab words thrown in here, and we've got congruent circles and congruent arcs. So congruent circles are when 2 circles have the same exact radius. Congruent arcs are when we have 2 arcs with the same measure, and, you have to remember this and, they are arcs of the same circle, or they could just be congruent circles. Okay, so looking at our figures down below, notice we've got the red, and we need to tell, are the red arcs going to be congruent? So I put it in question format underneath the picture, so those of you that can't see the colors on your own paper, you can at least follow this along. So in the first one, is arc CD congruent to EF? So first of all, they have to have the same measure. So we do have the same measure, that works. But they also need to be from the same circle, or they need to be congruent circles. But these are from the same circle, and they do start at the same exact central location. So that means that the arcs will be the same in this one. So yes. So they're from the same circle, and they have the same measure. All right, so letter B is arc RS congruent to arc TU. And if you look at it, they are from the same, or they overlap the same central location, but they're not exactly the same circle, but they do have the 90 degrees. So they have the same measure, but not from the same circle. So this would be a no. They are not congruent. If you look at them, you can tell that one is bigger than the other one. So then for letter C, is arc VX congruent to arc YZ, and they are congruent circles, and we know that they're congruent circles because they have the same radius. So we have congruent circles, and if they're congruent circles and they have the same measure, then we can say yes, that they are congruent arcs.